Okay, so let's try to be a little more general and launch our object upwards from ground level, not at t equals 0, but at some time t naught. Okay, so that's some number. Okay, so let's rederive our kinematic equations. dv y by dt equals minus g. So we start from there. We get a vy equation that looks like constant of integration minus g times t minus the original time, and a y equation, right? dy by dt is equal to vy, so we'll integrate that. We'll add a constant of integration, so we'll have plus v naught times t minus t naught minus 1/2 g times t minus t naught squared. And let's make a plot of this. Well, for some reason that's a little too high. Let's push this down a little bit and plot it down here. So this is time, and at t naught, at t equals t naught, we're launching the object up at speed v naught. So we have a speed v naught upwards. Let's find when it reaches the maximum height. So these are the two kinematic equations. The object reaches its maximum height when the speed is 0, so that equation is v naught minus g times t minus t naught. And that, of course, gives us that t is equal to v naught over g, plus t naught. And so we move to t naught plus v naught over g. So we're somewhere over here, t naught plus v naught over g. And the object should reach its maximum height. So it's like that. And what is the value of that height? Well, the y equation tells us that it's v naught, because y naught is 0, v naught times t minus t naught, but t minus t naught is v naught over g. So we get what we got before, minus 1/2 times t minus t naught squared, which again is v naught over g. And that, of course, gives us v naught squared over 2g. And so this height is this height here, this point here is v naught squared over 2g. And we expect it to come back down, and we can predict that it's going to come down at t naught plus 2 v naught over g. And of course, that will come from solving the y equation for y equals 0. And so that looks like 0 equals v naught times t minus t naught minus g over 2 times t minus t naught squared. And of course, that gives us t equals, in fact, or t minus t naught equals 2 v naught over g. And so t equals 2 v naught over g plus t naught, as expected. And we also expect the speed to be, the vertical component to be v naught but downwards. So let's find that. Vy equals V naught minus G times T minus T naught, but that's just 2 V naught over G. So in fact, we get minus V naught. And so here we would draw V naught downwards. So we just shifted the curve that we got last time by an amount T naught. So let's see what happens when we look at the equations choosing to have time increase and have time proceed in the negative direction. So our equations are Vy equals V naught plus G times T minus T naught, and Y equals Y naught minus V naught T minus T naught minus 1/2 G times T minus T naught squared. So we launched the object upward from ground level at T equals 0. Sorry, at T equals T naught. That's the whole point. We shifted that. It reaches max height when, let's just first combine these two, put them in bracket. 0 speed when this equation is equal to 0, and this will give us our time. T is in fact now minus V naught over G plus T naught. So let's see, so we have T naught, so if this is T naught, we launch the object up at T naught with speed V naught, and at, let's put it here, T naught minus V naught over G, this object reaches a height which should be the same as before. Let's make sure of that. Y equals Y naught, which is 0. We have a minus V naught times T minus T naught, which is minus V naught over G, minus 1/2 G times T minus T naught squared, which is minus V naught over G squared, and that in fact is V naught squared over 2G, so we have the same height, V naught squared over 2G, and we expect to come back down at a time T naught minus 2 V naught over G. So let's verify that. So ground level 0 equals minus V naught times T minus T naught minus 1/2 G times T minus T naught squared. And so, in fact, this gives us that T is equal to minus 2 V naught over G plus T naught. So it reaches the ground at that point, and of course we expect the speed to be minus V naught. Let's verify that. We have V naught, while we're looking at this equation, we have plus G times T minus T naught, which is minus 2 V naught over G, which in fact is minus V naught. So the object here has a speed V naught, but it's in the downward direction. So that we were a little bit more general by not fixing T naught equal to 0, and we again notice that whether we choose time to pass that way or that way doesn't make a difference.